According to a new unpublished study, one of the brightest stars you can see in the night sky is likely to explode within our lifetime. The star in question is a red giant called Betelgeuse. It's located in the left shoulder of the constellation of Orion. The star might have no more than 300 years' worth of fuel left in its core. Once it burns through these last reserves, the core will collapse, forming a black hole. As for the star's outer layers, they are likely to be blasted out into space at a mind-boggling 25,000 miles per second. This is what astronomers call a supernova. If Betelgeuse goes supernova, it will be a spectacular sight to watch from Earth. The star is comparatively not far from our planets, just 650 light-years away. So those layers of ejected gas and dust will shine as bright as the full moon. It will also last for several weeks. Interestingly, most astronomers don't believe Betelgeuse is ready to go kaboom yet. Then, what makes the authors of the new paper think otherwise? Well, this star is definitely a red giant that has burned through its primary fuel, hydrogen. At the moment, it's most likely fusing helium remaining in its core into some heavier elements. The point at which a star runs out of its hydrogen is unmissable. When a star is short on hydrogen, it needs to put extra energy into igniting the helium created during the process of hydrogen fusion. These additional efforts make such a star expand dozens of times beyond its original size. It also becomes redder and cooler in the process. Astronomers know that Betelgeuse is very, very large. If you placed it at the center of our solar system, its outer atmosphere would reach so far that it would swallow Jupiter. But it's hard to measure the exact diameter of the star. All because Betelgeuse is not your regular smooth ball of plasma. Instead, it's a lumpy chunk of boiling gas bubbles hiding behind dust clouds. This is the main reason why measuring the size of the star isn't easy. But to determine the star's remaining lifetime, we must know its diameter. And a team of scientists from Japan suggests that Betelgeuse is larger than most astronomers think. The star is known to pulsate. It expands and shrinks, dims and brightens again and again at regular intervals. Researchers link these changes to the periodical expansion of the star's outer region. There are other oddities in the behavior of the star. They appear on a regular basis too. Astronomers see the connection between these quirks and turbulent processes taking place inside the star, which seems ready to go out. The research team behind the new study believes that Betelgeuse's main pulsation mode is represented by the 2,200-day cycle, and the 420-day brightness variation might be the star's secondary quirk. For this scenario to work, Betelgeuse needs to be up to 1/3 wider, and to be as wide as necessary for this model, the star has to be in a later stage of its life, done with burning helium and, instead, running on carbon received from previous fusion of helium atoms. Whether a red giant is burning helium or carbon makes a great difference in terms of how much time it has left. If it's still in its helium-burning phase, the red giant can live for tens of thousands of years. But if it's already in the carbon-burning stage, the end is near and might come within a few thousand years. In the case of Betelgeuse, we can't determine exactly how much carbon the star still has, but carbon exhaustion might happen as soon as in 300 years. After that, fusions of heavier elements might take a few dozens of years. When it's over, the core will collapse and a supernova explosion will occur.
Betelgeuse, a red supergiant. This ball of boiling plasma is one of the largest stars in our galaxy and one of the brightest. It's about 500 times larger than the Sun. But Betelgeuse is pulsating, getting bigger and smaller. At its peak, it becomes 800 times its average size. If this star were a bucket, it would fit about 300 million suns, even though its weight is only 17 times greater. And here, about 500 light-years away, is Earth. We launch our faster-than-light spaceship and set off on our journey to Betelgeuse. A few seconds, and we've already traveled 240,000 miles, and now are close to the Moon. That's 9.5 trips around the Earth. A traditional rocket-powered spacecraft would take 3 days to get here. We're near Mars now. The flight to the red planet usually takes about 7 months. Several rovers are now at work here, as well as the first ever flying drone, Ingenuity. The surface of Mars is 3 times smaller than that of Earth. The planet is also 10 times lighter. People hope to build a human colony here soon. Right beyond Mars, we have to wiggle and constantly dodge space rocks. This is the asteroid belt. It contains debris and space objects of different sizes and shapes. The biggest of them is Ceres. Its surface is slightly larger than the area of Argentina, and its weight is about 1% of the Moon's. The total weight of the entire asteroid belt is 25 times less than the Moon's. Next, we pass gas giants Jupiter and Saturn. These are the largest planets in the solar system. They're also the heaviest, even though they don't have a solid surface. Then, we travel by Uranus and Neptune. They're called ice giants. And at the very edge of the solar system, we see Pluto. It was once considered a full-fledged planet, but now it's not even on the list. After that, we're 4.3 billion miles away from our home. It took the New Horizons space probe about 9 years to get here. Hold on to your seat, we're speeding up! We're passing through the Kuiper Belt. There are lots of asteroids and blocks of ice here. These are some of the oldest building materials in our solar system. Billions of years ago, our whole world looked like a cloud of these asteroids. We're traveling further through dark space and reach the edge of the solar system, the heliosphere. All this time, we've been moving with the solar wind, but now it starts to slow down, collides with the interstellar wind, and heats up. This is called the termination shock. The Voyager 1 space probe got to this point in December 2004. We're moving to the region where the heliosphere ends and interstellar space begins. This is the heliopause. In 2012, Voyager crossed this boundary and became the first ever human-made object in interstellar space. But the message from Voyager reporting this event came to Earth almost a year later because of the huge distance. It took 35 years for Voyager 1 to travel all this way. And here it is. The probe is as long as a car and weighs like 2 motorcycles. You can see a gold plate on its hull. It's a message from people to potential civilizations out there. It has pictures of Earth's landscapes, recordings of human speech, and our DNA. As of 2021, Voyager has been operational for almost 43 years. The probe has traveled 14 billion miles. That's like 152 Earth to the Sun distances. And it's still making its way through space at 38,000 miles per hour. Now, we're approaching the nearest star to our solar system. It's Proxima Centauri. We're so far from home that even light needs more than 4 years to travel this distance. If we used a traditional rocket, the trip would take us 73,000 years. The reason we wanted to get here was because of an Earth-like planet called Proxima Centauri b. It's 10% larger than Earth and slightly heavier. It lies in the habitable zone of its host star. It means that water might exist on the planet in its liquid state, and there can be life that forms here. But the star itself occasionally produces flares. Recently, its brightness increased almost 1,000 times. During that time, it emitted so much radiation that even if there were some forms of life on the planet, they probably ceased to exist. We're now more than 8 light years away from Earth. The brightest star in our night sky is Sirius. Seriously. It's so bright that you can see it even during the day. But in reality, there are actually 2 stars, Sirius A and B. They orbit around a common center of gravity, and these stars are moving toward our solar system at almost 5 miles per second. That's the same as the maximum speed of a top-of-the-line supercar on Earth. Foot down, and we've arrived at a potentially habitable planet, 39 light-years away from Earth. This is TRAPPIST-1d. Its host star is a white dwarf. It's a cold star, 10 times smaller and lighter than the Sun. There are 7 planets around it, but TRAPPIST-1d is the most similar to Earth. It's only 30% smaller and 3 times lighter, but it has a rocky surface and the temperature here is 48 degrees Fahrenheit. You'd feel comfortable here wearing a light jacket. There might be an atmosphere, mountains, seas, and oceans here, which means this planet might be suitable for a human colony. But it would take about 677,000 years to get here using traditional rockets. And here's our main goal: Betelgeuse. It'd take nearly 8.7 million years to travel here from Earth in a current-day spacecraft. This star is so big that our ship looks like a grain of sand on a giant beach. We have to jump back in time to find out what happened to this star. First, there was a beautiful nebula. It's a cloud of multicolored space dust and debris. Then, it began to shrink under its own weight. In the core of the nebula, a nuclear reaction began. Boom! And the star was born. At first, Betelgeuse was very massive and hot, but it didn't expand and remained stable. Let's look into its heart. The nuclear reactions in the star's core create a lot of heat and energy. This energy produces the force that pushes on the walls of the star from the inside and causes it to expand. But at the same time, the star is very heavy. That's why gravity pushes on it from the outside. If these two forces are balanced, the star remains stable. But over time, the star runs out of its fuel, helium and hydrogen. That's when heavier elements in the core join the nuclear reaction. When they burn, they release more energy and heat than gravity can hold, and the star starts expanding. That's what's happening to Betelgeuse right now. It's already so big that if you put it in the center of our solar system, its edge would touch the asteroid belt between Mars and Jupiter. Betelgeuse will continue to expand until it exhausts its fuel completely. Then the gravity will win. The star will shrink in size, and then an enormous boom will happen. A supernova explosion will be so blinding that Betelgeuse will shine brighter than the moon in the night sky. Luckily, Earth is too far away for this explosion to cause any harm to people. A strong stream of matter that will be ejected from the explosion site won't reach the solar system until 6 million years later. Even so, the solar wind will stop this flow, so we'll be safe. Betelgeuse is likely to explode at any time in the next 10,000 years, but some scientists say it won't happen in the next 100 millennia. Back to the moment before the explosion of Betelgeuse, there can be another, more interesting scenario. Gravity might compress the massive core of the star with such force that a black hole will appear in its place. Black holes are the heaviest objects in the universe. They have incredible gravitational force. Even light can't escape their gravitational trap. The Betelgeuse black hole will begin feeding on cosmic dust and whatever is left of the star. All this debris and light from other stars will get frozen near the event horizon of the growing black hole. For the first time in history, we'll be able to watch the birth of this mysterious object. But in reality, Betelgeuse is too light to become a black hole. Most likely, after the explosion, it'll turn into a white dwarf that will gradually fade until it becomes invisible. All the stars we see, including our sun, are in a balance of powers. Stars are very heavy objects, so they have strong gravity, which presses them from the outside and makes them shrink. But inside a star, while it burns fuel, there are nuclear reactions that produce incredible amounts of energy. This energy is the light and heat that we feel during the day. But most importantly, these reactions increase the pressure inside the star and create a force that is fighting with gravity. So as long as the star has a full tank, it's safe. But then, the fuel runs out, the pressure inside the star falls, and the gravity wins. A star the size of our sun can shine for about 10 billion years. Specifically, our lovely sun is about 4.5 billion years old and has already burned half its fuel. The next stage in a star's life comes when it runs out of juice. Internal pressure drops, but gravity continues to press. At some point, a star simply collapses under its own weight and shrinks to the size of its core at the speed of almost a quarter of the speed of light. In less than half a second, a huge star turns into a small and dense object. This rapid collapse creates incredible shock waves that cause the upper layers of the star to explode. Now, an incredible amount of energy and matter is thrown into outer space. At this moment, luminosity of the star increases millions or even billions of times. This is the flash that our scientists can see with super powerful telescopes. But the light from this explosion doesn't reach our planet until many years later. So in fact, this star has long since faded. There are several options at this point. It all depends on the size of the star. If its mass is small, about the mass of our sun, then for several months, this flash will become brighter and brighter until it reaches its peak. Then, the energy of the explosion will begin to dissipate, gradually fading and cooling down. A few years will pass, and the temperature of the former star will match that of space, and it will simply cease to exist. But the heavier the star, the more interesting the events will be. Heavy stars burn their fuel too quickly and have a much shorter lifespan. Stars weighing about 8 masses of the Sun can collapse into a rather unusual object, which is rarely found in the universe, a neutron star. This dull ball is only 6 to 12 miles wide and covered with a hard metal crust about half a mile thick. Neutron stars can weigh about 2 suns and have a strong gravity force. If you feel comfortable and in good shape on Earth, you wouldn't even be able to lift a needle or a match here. What's more, you would be pressed to the surface like a pancake and just unable to move. But there are stars dozens of times heavier than the Sun. An explosion of such a supernova, which weighs at least 40 times more than the Sun, gives birth to the most inexplicable and mysterious object in the universe, a black hole. At first, an incredibly bright explosion occurs. A shockwave spreads, carrying dust and matter of the former star around like a fog. And at the place of the explosion, only a small black disk is left. This black abyss is the heaviest object in the universe. It's so heavy that its gravity curves space-time around it. Yes, the closer you are to a black hole, the slower time will go for you. If you could get close enough to one of them, spend a couple of minutes in its orbit, and return to Earth, you would simply not recognize your home. 1 minute near a black hole can be a month, a year, or a decade on Earth. This depends on how heavy the black hole is. But don't get too close. The force of its gravity is so strong that even light can't escape from it. Humanity also knows about the existence of supermassive black holes. They gradually build up their mass, feeding on different cosmic objects just like a predator. Usually, such supermassive black holes lie in the centers of galaxies, and their gravity is so strong they can hold countless stars near them. For example, this is the only photo of a black hole, which is located in the center of the Messier 87 galaxy. The orange glow around it is its event horizon. That's the remains of the light from the objects this black hole has swallowed. You're quite safe though. The closest black hole is 1,120 light-years away. But supernovae can explode not only when gravity wins the fight with the star's internal forces. Sometimes the opposite happens. The nuclear fusion inside the star begins to affect much more matter than normal. The pressure inside a star increases, and it defeats the force of gravity that exerts pressure on the star from outside. At this point, there's a boom! This never happens by itself, and this type of supernova is only possible in binary star systems. 2 stars are spinning around each other. One star begins to swallow the substance from the other. Then, the nuclear reactions inside it are no longer in balance, and a supernova explodes. For some time, scientists believed that such an explosion could occur in 2022. There's such a binary system in the Swan constellation at a distance of 1,800 light-years from the Sun. The luminous red nova should have occurred here. Such a red flash would have been visible to the naked eye for months. And after the explosion itself and the merger of 2 stars, a new, hotter, and heavier star was to appear in their place. But a new analysis of the data revealed a calculation error, and this event will not happen soon after all. So now we see that a supernova explosion is a very dangerous event, and it can cause great harm to our planet if it happens close enough. The main danger is gamma rays. This is the radiation that comes from the explosion. When these rays reach the Earth, they affect our space shield, the atmosphere. They reduce the ozone layer and make us vulnerable to solar radiation and cosmic rays. In this case, all life on the planet is in incredible danger. And the bad news is that such an explosion could happen quite soon. Betelgeuse, the brightest star in the night sky, about 17 times larger than the Sun and 8.5 billion years old. It's begun to exhaust its fuel reserves. Scientists predict that this giant will explode like a supernova at any moment within the next 10,000 years. So it may happen in a few centuries or even tomorrow. Everything will happen as follows. Betelgeuse will collapse in a fraction of a second, and then it will explode so brightly that it will look like a second moon in the night sky. We will observe a new bright spot in the sky for weeks or even months. But then, it will begin to fade until it completely disappears. Not without a trace though. In its place, there will be a neutron star, weighing 1.5 times the Sun. It will be one of the biggest events that humanity has ever seen. Still, we have nothing to be afraid of. Betelgeuse is about 550 light-years away from us, so its X-rays and ultraviolet light will not affect us. A much greater danger is posed by the release of material that occurs in a supernova explosion. But this shouldn't make you worried either. The shockwave won't reach the Earth until 6 million years later, and it will be suppressed by the oncoming solar wind. So if we see Betelgeuse explode today, it will be an epic sight. But in fact, the star will not exist at the time because it will mean the event itself happened almost 6 centuries ago. It's just that now the light from it has reached us. Some scientists believe that the Ordovician Silurian extinction events, which occurred almost 500 million years ago, happened exactly because of a star explosion. Then, almost 60% of marine vertebrates went extinct. Yet, it was not a supernova, but a hypernova. That is what scientists call explosions of stars 100 to 150 times larger than the Sun. In addition to the abnormal weight, the star must rotate very quickly. Such objects are very rare. In our galaxy, there are few of them, and scientists believe that hypernovae occur about once in 200 million years.
Now, it's been a long time since there was a supernova in the Milky Way, over 400 years to be precise. So hey, we're long overdue. So here are the most likely stars to go boom, if they haven't already. At the top of the list must be the Southern Hemisphere star Eta Carinae. Greek letters before the name of the constellation indicate the rank of the star's brightness in that constellation. Sir Edmund Halley, in 1677, recorded Eta Carinae as the 7th brightest star in the constellation Carina, Eta being the 7th letter in the Greek alphabet. It might not have looked very bright to Sir Edmund and his contemporaries in the 17th century, but modern studies of Eta Carinae estimate it's 5 million times more luminous than our Sun. Luminous is a technical word astronomers use. It doesn't just mean brightness. Luminosity refers to the total energy released at all frequencies. Eta Carinae releases 5 million times more energy than the Sun. Truly one of the whoppers of the Milky Way, Eta Carinae is 100 times more massive and 240 times larger than our yellow-white dwarf sun, Sol. Obviously, since it appears dim, Eta Carinae is pretty far away, about 7,500 light-years away. Yet even at this distance, if this star goes hypernova, it can still impact Earth's ozone layer, disrupt satellite communications, and harm astronauts. 159 years after Halley's observation, Eta Carinae experienced a nova-like explosion. It increased from a relatively dim star to become the second brightest star visible from Earth, but only for a period of 27 years. From 1836 until 1863, Eta Carinae was the second brightest visible star after Sirius, the dog star, and Sirius is only about 8 light-years away. Since 1863, aside from a couple of flare-ups, Eta Carinae has dimmed back down to its original brightness at magnitude 4.5. Now, astronomers owe us a small apology, which we don't expect to get anytime soon, for star magnitude nomenclature. The brighter a star is, or planet, or moon, the lower its magnitude. Thus, stars brighter than first magnitude are either 0 magnitude or negative magnitude. The full moon, for example, is magnitude -13. A magnitude positive 4.5 star, like Eta Carinae, is quite dim as seen from Earth, but it's clearly visible in a night sky without light pollution or clouds if you live anywhere south of the latitude of Cairo, Egypt. 30 degrees north latitude is the farthest north you can see this star. Now, listen up. Eta Carinae is currently up to something. It's been brightening again and is now brighter than at any time since 1864. It's a complex situation. Eta Carinae is really 2 stars, Eta Carinae A and Eta Carinae, what's your guess? Oh, B. There's a third star nearby that's also interacting with the double star's dynamics. Now, without looking, I'm guessing it's named Eta Carinae C. Good guess. Blown out into 2 incredibly massive globes of gas that are expanding at 20 million miles per hour, Eta Carinae is, without a doubt, one of the strangest looking stars you'll ever see. Remember, it's located at a great distance of 7,500 light-years away from us. And if anything had happened to Eta Carinae in the last 7,500 years, like going hypernova, we wouldn't be able to see it, because none of Eta Carinae's electromagnetic radiation would have gotten here yet. Astronomers are keeping a close watch on Eta Carinae because it can go hypernova at any time. Or maybe it already did 5,000 years ago, in which case we'd only have to wait another 2,500 years to see it. Yeah, like I'll put it in my planner. Now, from a list of over 30 likely candidate stars that might go supernova, Rho Cassiopeiae is many astronomers' choice. Another Greek letter, Rho, is the 17th letter in the Greek alphabet. It means that Rho Cassiopeiae is the star with the 17th brightest apparent magnitude in the constellation Cassiopeia. Yet Rho Cass, a nickname, is only one of 7 known yellow hypergiant stars in the Milky Way. It's another whopper. To be seen at magnitude 4.5 from a distance of about 10,000 light-years away, Rho Cass must be a very large star, a hypergiant. Placed where the Sun is, Rho Cass would encompass the orbit of Mars. But it's still yellow. It's not a red giant star. Red indicates a cooler surface temperature. Rho Cass, as huge as it is still as hot on its surface as our Sun, or even a little hotter. That can only mean 2 things. Deep inside its core, Rho Cass is fusing atoms much heavier than hydrogen or helium. Plus, Rho Cass is producing much more energy than a red giant star. In the year 2000, Rho Cass erupted massively. It brightened by 2 orders of magnitude as it ejected 10,000 times the mass of Earth into space at 4 times the speed of sound. Astronomers detected the signature of titanium oxide in this eruption. This means that Rho Cass is much closer to going supernova, or in this particular case, hypernova, than astronomers used to assume. Iron is just a few steps above titanium in the periodic table, and when iron forms, fusion stops and a star collapses. Rho Cass is really close, or more correctly, was really close, because the eruption we saw in the year 2000 really happened 10,000 years before. Many astronomers think Rho Cass has already gone hypernova, formed a black hole, and doesn't even exist anymore. Meanwhile, Betelgeuse caught everyone's attention not so long ago. The star, not the movie. It dimmed dramatically, appearing only 37% as bright as it usually is. Is it getting ready to go supernova? Betelgeuse is by far the brightest star in the whole sky, in infrared light. This is an important fact because it relates to Betelgeuse's status as a supernova candidate, as we shall soon see. Betelgeuse is also named Alpha Orionis, another Greek letter designation. So we should conclude that Betelgeuse is the brightest star in Orion, right? Wrong. It's the second brightest star in its constellation. Rigel, or Beta Orionis, is the brightest one in that region. Figure that one out. It may be because Betelgeuse is classified as a semi-regular variable star, which sounds kind of redundant to me. Its approximately 400-day cycle of pulsation changes its brightness by about one full magnitude, going from much brighter than a first magnitude star to closer to a second magnitude star. But never was Betelgeuse observed to dim so rapidly or so drastically as it did recently. So what's going on with it? Well, from late 2019 to mid-2020, Betelgeuse went through a period of substantial dimming during a mass ejection event. The world astronomy community jumped on the situation, and in the course of their investigations, they came up with some surprising new factual data on Betelgeuse. First, Betelgeuse is not as far away as we once thought. The new, more accurate distance for Betelgeuse is 548 light-years. That's 25% closer than previously measured. The second new fact, Betelgeuse's diameter has been reduced by the same percentage. The star is now known to be 25% smaller than previously believed. The cause of Betelgeuse's dramatic dimming was also determined. The giant star ejected a cloud of gas that contained magnesium. The cloud blocked a large portion of the light coming from Betelgeuse and made it appear visually much dimmer than it really was. Magnesium is not halfway to iron on the periodic table, which means Betelgeuse is not as far along on the path to a supernova as was suspected previously. When iron starts forming in the star, it means that this star is close to shutting down its fusion reactions. The next step is implosion. We aren't quite there yet with Betelgeuse. This star emits most of its energy as infrared light, and it also indicates that its core is most probably still burning helium, and not something that would greatly increase the amount of heat, like carbon for instance. Betelgeuse will still go supernova, but not for another 100,000 years. So you can cross it off your supernova list for the time being. And as for how to correctly pronounce Betelgeuse, you can say it any way you like. There are as many different pronunciations out there as there are people who think they know how to pronounce it correctly. Now, supernova 1987A caught astronomers off guard when it lit up the large Magellanic Cloud 100,000 plus light-years away from the Milky Way. That's when attention was turned to a similar star much closer to Earth, Rigel, in the constellation of Orion. Could Rigel surprise us and suddenly go supernova? There's something called the supernova problem that you should, probably know about because it may relate to Rigel going supernova or not. It seems that stars over 17 solar masses don't always go supernova. Recently, a red giant star simply vanished. Once again, it didn't go supernova, it disappeared. This had often been happening in computer simulations of supernovae, and now it finally occurred in real life. Rigel's mass is 21 solar masses. In other words, it's 21 times more massive than our Sun. So, will Rigel go supernova or simply vanish into a black hole that it'll create in its core? Astronomers and physicists continue their work of learning more about the dynamics of massive stars, scouring the sky for the next supernova in the Milky Way. Meanwhile, we can rest confident that we on Earth are in no danger from the harmful effects of nearby supernova explosions. We live in a nice, quiet, peaceful, stellar neighborhood, except for those Martians next door. Castles were cold places in times past. The stone seemed to radiate the winter chill. This is one practical reason why tapestries were hung upon castle walls, to help keep the cold out and the warmth in. But you just can't hang any old thing on castle walls. It should be beautiful, heroic, with a heavy wow factor. The ancient Greeks hung tapestries on the walls of their castle of the sky, glorious tapestries woven of stars. All 48 constellations of the Northern Hemisphere were designed and named by the Greeks. The story of Andromeda is one such tapestry, woven of 7 constellations spread across the entire autumn sky. The story contains detailed astronomical observations preserved as highlights in the sky tapestry. It begins with the constellation Cassiopeia, queen of the oldest realm in Africa, Ethiopia. When the constellation Cassiopeia is on the horizon, it looks like a staircase going up to the Milky Way. Step pyramids around the world are often thought to have been inspired by the constellation Cassiopeia. In any case, Cassiopeia is a beautiful constellation, indicating that Queen Cassiopeia was also a beautiful woman. She was good-looking, but equally vain, which sets off all the dramatic action. Cassiopeia can be found in the night sky opposite Ursa Major from the North Star. Like Ursa Major, Cassiopeia circles the North Star and is a circumpolar constellation. A supernova was observed in Cassiopeia around 1680 Earth time, Cassiopeia A having occurred about 11,000 years earlier. The Chandra X-ray satellite recently recorded an extraordinary photograph of this supernova remnant, showing the elements sulfur, calcium, silicon, and iron amid the expanding cloud's high-intensity X-rays. Cassiopeia's husband is also a circumpolar constellation, a minor, dim one named Cepheus. He had his own kingdom. A merger of empires by way of marriage is something common throughout history. Cepheus was a king of Phoenicia. There were many kings of Phoenicia back in the days when Phoenicia was just a collection of city-states along the western shore of the Mediterranean Sea. Cepheus can be found in the area between Cassiopeia and the North Star. The constellation of Cepheus is important to astronomers. It's where Henrietta Swan Leavitt discovered variable stars that pulsed at regular intervals. The rate of pulsation of the star indicates the true brightness of the star and enables a sure measurement of the distance to the star. The discovery of Cepheid variable stars was a major breakthrough for early 20th century astronomy. Cepheus and Cassiopeia had a daughter, Andromeda, also a noted beauty, about whom all the fuss is. It seems that one day Cassiopeia was boasting about the beauty of her and her daughter Andromeda. "We are more beautiful than any other women in the whole wide world." Well, such pretension can be forgiven for a queen. But then Cassiopeia went further and stepped beyond all natural bounds. In fact, "We are more beautiful than any of the Nereids." Well, the Nereids were Greek mythological sea nymphs, daughters of the ocean. Noted for their beauty and kindness to sailors, the Nereids, all 50 of them, took offense at being dissed by a mere mortal woman. Cassiopeia had to be punished for exceeding the bounds of the civil order. By her excessive vanity, Cassiopeia transgressed beyond the bounds of nature, for which an unnatural punishment was inflicted upon the entire kingdom of Ethiopia. A monster from the bottom of the ocean, the constellation Cetus, began to devastate the coastal villages of Ethiopia as well as Ethiopia's fishing ships. Fittingly, Cetus is a constellation of the southern celestial hemisphere. The fourth largest by area of all the constellations, Cetus swims in a dark part of the sky called the ocean, with only its head rising above the celestial equator. This part of the sky contains several water-themed constellations: Pisces, the fishes, Aquarius, the water-bearer, and Eridanus, the river. Over 50 exoplanets have been discovered in Cetus. You can bet the James Webb Space Telescope will have a field day analyzing the spectra of these planets' atmospheres, looking for signs of life. Meanwhile, Queen Cassiopeia and King Cepheus must do something about the monster devastating the shores of Ethiopia. They consult an oracle and make another trespass beyond the realm of reason and nature. "Tell us, oracle, what can we do to stop the monster from ravaging our kingdom?" This monster is not a normal affliction of nature. An offense was committed against the higher realms, and this is the punishment. The monster cannot be stopped by any normal means. Only a human sacrifice of the noblest being may placate the beast. One error compounds another. The noblest person in the kingdom, of course, is Princess Andromeda. According to the command of her father and the consent, or perhaps a suggestion of her mother, Andromeda is chained to a rock offshore. She is the human sacrifice that her parents hope will save the kingdom. Wow. Da-da-da-da! Here comes the Greek hero to save the day, stop the human sacrifice, and turn Cetus to stone. Perseus. Now, where is Perseus coming from? According to legend, the Hebrides. Perseus went to the Hebrides in pursuit of the Gorgon Medusa. The geological scope of this tapestry is incredible, from the Hebrides to the Red Sea. The Hebrides are an archipelago of mostly rocky islands off the western coast of Scotland. It was impossible to sail any further. The Hebrides were the absolute end of the world. Perseus didn't have to sail to the Hebrides. However, he flew on a pair of winged sandals. Hey, way to go, Perseus! Now, Medusa was one of the all-time baddies. One look at Medusa was so terrifying it would petrify you, literally turn you to stone. Perseus was in great danger. So, what did our hero do? Instead of looking at Medusa, Perseus used the scientific principle of reflection. He slew Medusa by seeing her reflected in his polished shield. In our sky tapestry, Perseus is portrayed holding up the severed head of Medusa. In the night sky, one eye in Medusa's head opens and closes and opens again. Arabic astronomers named the star Algol, the ghoul. Algol is an eclipsing double star. One star is bright, the other one, not that much. As the dimmer star orbits the bright star, it passes in front of the bright star, eclipsing it, and the eye closes. Since the dim star takes 2 days, 20 hours, and 49 minutes to orbit the bright star, the eye in Medusa's head opens every day and a half or so. The constellation of Perseus is immediately below Cassiopeia, and sky watchers quickly look to see if Algol is eclipsed, if Medusa's eye is open or closed. Perseus flew back from the Hebrides, accompanied by Pegasus, the winged horse. The central part of Pegasus is the Great Square, made up of 4 stars. As Earth goes around the Sun, the Great Square is right in the center of the night sky in autumn. In the summer triangle of Vega, Deneb, and Altair are in the middle of the night sky. In spring, it's Leo the lion, and in winter, it's Orion the hunter. These are the walls of the castle in the sky, and all have marvelous tapestries adorning them. The constellation of Andromeda shares a star named Alpheratz with Pegasus. It's one of the corners of the Great Square, so it appears Andromeda may be riding on Pegasus. Her crown, remember she is a princess, is floating nearby. M31, the Andromeda Galaxy. To see M31, cross the corners of the Great Square from the lowest star to the uppermost star, and then go a little further to see the Andromeda Galaxy. Be sure to peek at it from the corner of your eyes. It's called averted vision. The corners of your eyes are more sensitive to light, so you'll be able to see the huge spiral galaxy 2.5 million light-years away as a smudge of light, 1.5 times wider than the full moon. Now, Perseus doesn't go in for human sacrifice, so he stops it and saves Andromeda by exposing Cetus to Medusa's gaze. And here we encounter the second eclipsing variable in our sky tapestry, Mira, the heart star of Cetus, the sea monster. Mira, from which we get the English word mirror, so fitting in a story about vain beauty, is an eclipsing double star. The dim star orbiting the bright star is a white dwarf, not bright enough to see with the unaided eye. The effect is that Cetus's heart shuts off. Mira is eclipsed and disappears. This cycle repeats itself every 332 days. Our fabulous star tapestry has the only 2 eclipsing binary stars visible to unaided eyes, the nearest spiral galaxy, and a hero that doesn't like human sacrifice and uses the scientific principle of reflection to thwart mythological monsters. Wow, I would hang that in my castle too. Just saying.
It was the year 2017 when astronomers spotted a bright star hurtling out of the Milky Way. It was moving incredibly fast at a speed of 2 million miles per hour. That's almost 4 times as fast as the Sun orbits around the center of our home Milky Way galaxy. It takes our star more than 225 million years to complete one journey. Anyway, back to our star, the Wanderer. The main issue with it was that it was moving against the direction in which most stars travel around the center of our galaxy. Even more bizarre, it consisted of totally different star stuff. Astronomers managed to identify its composition. The star was made up of heavy metallic atoms. At the same time, most of the other stars consist of way lighter elements. The wandering star got the name LP-40-365. It was moving so fast that it literally dashed out of our galaxy. This made scientists believe that the space traveler was pushed out of its place by some kind of cosmic disaster, like a supernova. A supernova is the largest explosion that can take place in space, an explosion of a star. It happens after irreversible changes start in the core of a star. Supernovas can occur in two ways: in binary star systems and when there's a single star. Binary stars are two stars orbiting around the same center. At some moment, one of the stars, a very dense white dwarf, starts stealing matter from its companion. After some time, this thief accumulates too much matter, which causes it to explode into a supernova. Or it can be a single star nearing the end of its life. It's running out of its fuel. More and more mass is flowing into the core of the star. In the end, the core becomes so heavy that it fails to withstand its own gravity. After the core collapses, a tremendous amount of energy is released in a supernova. But astronomers still can't figure out how a supernova could send LP-40-365 flying. There are more questions than answers. Was it a companion star that got flung out by a shockwave created by a supernova? Or was it a piece of the exploded star? A new study based on the collected data has shown that the star, which is a white dwarf, keeps slowly rotating around its axis. Astronomers are almost sure it means LP-40-365 is indeed just a chunk of space debris, and not a full-fledged star. This wandering piece somehow managed to survive one of the fiercest space events. But after making such a conclusion, scientists realize something amazing. LP-40-365's unusual features could appear after the star witnessed a supernova. Even though this event happened lightning fast, the entire makeup of the star got changed. Most stars consist mainly of helium and hydrogen, but LP-40-365 is different. It contains such heavy elements as magnesium, oxygen, and neon. It must have been the supernova that added these atoms to the star's composition. By the way, astronomers consider all elements that are heavier than helium to be metals. This means that after witnessing the supernova, LP-40-365 became metallic. Right now, the star doesn't have its own planets, but NASA's Transiting Exoplanet Survey satellite, which is on the lookout for distant planets passing in front of their host stars and dimming them, has noticed a curious thing. LP-40-365 brightens and then dims again every 8.9 hours. It might mean that the star pulsates, but usually stellar pulsations are much less regular. A more plausible explanation is that the star's surface is uneven, and as it spins, sunspots are brought into and out of view. And it's great news, because after astronomers figure out how fast the star rotates, they can understand what happened to it around 5 million years ago during the supernova. Bright blue exoplanet HD 189733b looks peaceful and eerily familiar. Doesn't it resemble Earth? But this appearance conceals the planet's terrifying nature. There, the winds blow at 5,400 miles per hour. It's 7 times the speed of sound. But that's not the worst. It rains glass, sideways, in this scorching hot world. Neutron stars are ultra-dense collapsed cores of giant stars. They emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. The most plausible theory is that this signal was probably produced by a disk of dust surrounding the star. But there isn't enough evidence to confirm this idea. Mercury is the fastest planet in the solar system. It zips around the sun at a breakneck speed of more than 100,000 miles per hour. That's around 40,000 miles per hour faster than our home planet. It's one of the reasons why a year on Mercury equals 88 days on Earth. Mercury is the planet that orbits the closest to the sun. That's why if you were standing on its surface at its closest approach to our star, the sun would look more than 3 times as large as it does on Earth. The Black Widow pulsar is a rotating neutron star that is munching on its partner, which is a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. There's a stellar nursery in the constellation Centaurus, and even though this place is called a nursery, it's anything but peaceful or safe. It's made up of hydrogen and newborn stars and is located in a nebula around 6,500 light-years away from Earth. A nebula is a giant cloud of gas and dust floating in space. The intense energy baby stars emit makes hydrogen clouds glow ominous red. This energy is so powerful, it's eating away dark clouds of dust. Astronomers can see them disappear like lumps of butter on a hot frying pan. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice, and this ice is burning. The planet completes one full orbit around the red dwarf Gliese 436 in just 2 days. It means the exoplanet travels very close to its parent star. That might be the reason why the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet hosts huge volumes of water ice known as Ice X. And this ice remains solid despite such incredibly high temperatures. Jupiter is the largest planet in the solar system. It's 318 times as massive as Earth. It's also 2.5 times as massive as all other planets of the solar system combined. But here's a paradox. If this gas giant got even more massive, it'd actually become smaller. The added mass would make the planet denser, and this would cause it to start pulling in on itself. Astronomers claim that Jupiter can eventually end up being 4 times as massive as it is now. But at the same time, its size won't change. DGSAT-1 galaxy is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thin. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind. Those are usually found in clusters. It can mean that DGSAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Saturn's moon, Hyperion, is one of the most bizarre-looking moons in the solar system. But the appearance isn't the strangest thing about this space body. The pumice stone-like rock is pockmarked with countless craters, and it's also charged with static electricity, which is flowing out into space. About 4,000 light-years away from Earth, there's a planet that seems to be one enormous diamond. The planet is denser than any other discovered so far and consists mostly of carbon. It's so dense that astronomers think this carbon might be crystalline. It means that at least some part of the planet is diamond. Ceres is the most massive space body in the asteroid belt between Jupiter and Mars. It totals almost a third of the entire mass of the whole belt. But at the same time, Ceres is the tiniest of the dwarf planets out there. It's also the only dwarf planet that dwells in the asteroid belt, and also the only one that is located in the inner solar system. Astronomers sometimes call Jupiter a failed star. The gas giant indeed contains a lot of helium and hydrogen. But its mass isn't enough to start a fusion reaction in its core. And that's exactly how stars produce energy. They fuse the atoms of hydrogen together under extreme pressure and heat and create helium. In the process, they also release light and heat. Jupiter could start a nuclear reaction and become a star only if it was 70 times its current mass. Space is completely, eerily silent. That's because in the vacuum of space, there's no atmosphere, and the sound waves need some medium to travel through. That's why worlds with atmospheres like Earth are full of noise. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have enough mass of 1,000 sedans. One theory claims that tons of micro black holes could be created right after the Big Bang. Some scientists even go so far as to say that a couple of mini black holes pass through our planet every day. Every hour, the sun sends more energy to Earth than our planet uses in a year. Even though people are now using much more solar energy than a decade ago, it's still a mere 0.7% of the world's annual electricity usage. There might be moons orbiting other moons, but astronomers haven't agreed on this theory yet. Planets orbit stars, moons orbit planets. But why can't there be moons, also known as submoons, moonettes, and moons? Researchers claim that moons could exist, but the host moon has to be massive enough and the moon small enough. There must also be a large distance between these moons and the host planet. Jupiter is the most massive planet in the solar system. This means its gravity is also the most intense. It's 2.5 times as great as what we have on our home planet. Once, the gas giant's gravity even tore apart a large comet called Comet Shoemaker-Levy 9. Then the planet eagerly swallowed the chunks of the former comet. If you were standing at the equator on Mars, the temperature at your feet would feel like that of a warm spring day, but your head would be literally freezing. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars, but one of them, floating 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates never-ending flashing auroras in the planet's atmosphere. Europa is one of Jupiter's largest moons, even though it's smaller than Earth's moon. But the cool thing about this satellite of the gas giant is that it's covered with ice. And some of this ice is smooth, which means you could skate there. And a 3-foot axle jump you can perform on our planet would take you 22 feet into the air. At the same time, the landing speed on Europa would be the same as it is on Earth. Haumea, a dwarf planet orbiting the Kuiper Belt, has a bizarre elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning large object in the solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile wide ring circling it. Astronomers haven't managed to figure out how or why it appeared around the dwarf planet. 11 Earths could fit across the equator of Jupiter, and if our planet was the size of a grape, the gas giant would be as large as a basketball. 9 spacecraft have already visited Jupiter. 7 of them just flew by, and 2 orbited the huge planet. The most recent of them, Juno, arrived at Jupiter in 2016. The craters of the moon's south pole are likely to be the frostiest place in the whole solar system. The crater's floors are always in the shadow. That's why the temperature never rises above 397 degrees Fahrenheit, even during the day. If you decided to fly a plane to Pluto, your journey would take around 800 years. You'll find the highest mountain in the solar system on an asteroid called Vesta. Its peak rises 14 miles above the base of the mountain. This makes Rye Silvia, that's what the mountain is called, almost 3 times taller than Everest. Saturn's rings weren't discovered all at once. It happened gradually. That's why they were named alphabetically in the order scientists found them. Now they go like this: D, C, B, A, F, G, and E. A day on Venus is around 243 Earth days long. But the bad news is that you'd have to wait for a weekend for 3 years. All because a day on Venus is longer than its year. A solar phenomenon called terminator events is taking place at the sun's equator. Disastrous magnetic field collisions seem to cause ginormous twin tsunamis of plasma. These tsunamis tear across the star's surface, moving at a speed of 1,000 feet per second. They can last for weeks at a time and happen almost every decade. The winds on Neptune are the fastest in our solar system. Most of them can reach the speed of 1,600 miles per hour. Almost any of these enormous storms could easily swallow our entire planet. The 18th brightest star in the night sky, Fomalhaut, is a terrifying sight. It's dubbed the Eye of Sauron because a ring of dust and debris circling it makes it look like a giant eye staring into your soul. The intimidating star is more than twice the mass of our Sun and is 25 light-years away from Earth, which isn't that far away considering distances in space. Mars has 2 moons, Phobos and Deimos. In the next 30 to 50 million years, the planet's gravitational forces will tear Phobos apart. It'll probably result in the formation of a ring around Mars. An asteroid the size of a car enters the atmosphere of our planet every year. Such an intruder could wipe out a small town off the face of the Earth. dust and smoke would rise into the atmosphere, preventing sunlight from reaching the surface of the planet. It would cause the temperatures all over the world to drop and the climate would change. Luckily, such asteroids burn in the atmosphere before they even come close to the surface. The radio signal produced by a spacecraft when it contacts Earth is less powerful than a light bulb in your fridge. By the time this signal reaches our planet, its power is only 1/1000000000th of a watt. No wonder that antennas gathering these super weak signals are huge. The Deep Space Network that detects signals from spacecraft has dish antennas that measure up to 230 feet across. That's more than the width of a soccer field. In 1999, NASA lost a Mars orbiter because one engineering team was using the metric system, and another was doing calculations with the help of the imperial system. Nebulas are giant clouds of gas and dust. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger, and their gravity gets more powerful. One day, a nebula's mass becomes so great that it collapses under its own gravity and forms a new star. Around 4,000 light-years away, in the constellation of Scorpion, there is the Butterfly Nebula. Its wingspan is greater than 3 light-years, and the structure inside the nebula is one of the most complicated ever observed. The nebula's central star, a white dwarf, is heated to an insane 450,000 degrees Fahrenheit. This means it was formed from another huge star, likely more than 5 times the size of our Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass, or a butterfly. If you decided to lump together all the known asteroids in the solar system, their total mass wouldn't exceed even 10% of the mass of our Moon. A cloud of water vapor is floating in space. It surrounds a supermassive black hole 12 billion light-years away from Earth. The cloud contains 140 trillion times the entire volume of water on our planet. Astronomers think this water cloud appeared just 1.6 billion years later than the universe itself. The densest objects in space are neutron stars. They are the size of a small city, yet their mass is about 1.4 times the mass of our Sun. A single teaspoon of neutron star material would weigh 1 billion tons. And a neutron star's gravity is 2 billion times stronger than the gravity of our planet. In 1993, the Galileo probe was traveling past a miniature asteroid. It was no more than 20 miles across, and still, the tiny thing had a 1-mile wide moon. Astronomers have discovered tons of moons orbiting minor planets in the solar system since then. We live inside the Sun. The star's atmosphere stretches way beyond its visible surface, and our planet is well within its reach. That's how the gust of the solar wind creates such a breathtaking phenomenon as the northern and southern lights.